What is a heat wave?
A heat wave is a period of 2 or more days in a row when apparent temperatures on the National Weather Service heat index exceed 105 degrees Fahrenheit to 110 degrees Fahrenheit, 40 degrees Celsius to 43 degrees Celsius. The temperature standards vary greatly for different locales. Heat waves can be extremely dangerous. According to the National Weather Service, 175 to 200 Americans die from heat in an average summer. Between 1936 and 1975, as many as 15,000 Americans died from problems related to heat. In 1980, 1,250 people died during a brutal heat wave in the Midwest. In 1995, more than 700 people died in the city of Chicago from heat-related problems. A majority of these individuals were the elderly living in high-rise apartment buildings without proper air conditioning. Large concentrations of buildings, parking lots, and roads create an urban heat island in cities.
What is the speed of sound?
The speed of sound can vary, depending on air pressure and, more importantly, temperature. The conventionally accepted speed, which is useful for estimating the distance to a lightning stroke, is about 1 mile for every 5 seconds. More precisely, sound travels at 740 miles per hour, 1,191 kilometers per hour. At 1 atmosphere pressure when the temperature is 32 degrees Fahrenheit 0 degrees Celsius. Sound travels faster through water and many other media that are denser than air. In general, because the temperature of the air cools as altitude increases, sound is refracted upwards and away from people on the ground. Thus, measurable sound decreases the farther away one is from the source. On the other hand, the stratospheric layer of the atmosphere increases in temperature as altitude increases, thus refracting sound downward.
What is the solar spectrum?
The solar spectrum is the spectrum of light that includes wavelengths both visible and invisible to the human eye. When diverted through a prism, this white light separates into the familiar rainbow spectrum of colors, ranging from violet to red. Temperature is affected by the longer wavelength spectrum, red through invisible infrared. About 50% of the sun's spectrum emerges as wavelengths at the infrared level, and 10% are in the ultraviolet range.
How did Mikhail Ivanovich Budayko calculate the temperature of Earth's climate?
Mikhail Ivanovich Budayko, 1920 to 2001, was a Belarusian meteorologist and physicist. as well as a pioneer in the specialized field of physical climatology. He was the author of the 1956 book Heat Balance of the Earth's Surface. In this work, he used the principles of physics to explain, as no one had done before, how energy from the sun is absorbed and then radiated back into the atmosphere by the Earth. Bodico's research led him to become concerned about climate change. And he was one of the first to realize that a buildup of carbon dioxide created by human industry was causing the atmosphere to warm up. He predicted that by 2070 the average temperature on Earth would be 6.3 degrees Fahrenheit. 3.5 degrees Celsius, higher than 1950 temperatures. Bodico was also one of the first to predict that a nuclear winter would result from a nuclear war.
Is global warming causing an increase in severe hurricanes?
A 2005 Massachusetts Institute of Technology study estimated that because global warming is increasing ocean temperatures, hurricane frequency and intensity has increased by about 45% from just a few decades ago. In the 1970s, for example, the average hurricane season saw 10 hurricanes develop in the Caribbean area. By the 1990s, that number had increased to 18 annually. Hugh Willoughby, a researcher for Florida International University, has also asserted that hurricanes are getting stronger and more frequent. This has also become the position of scientists at the National Oceanic and Atmospheric Administration. Among the exceptions to this viewpoint is Florida State University professor James O'Brien, who has asserted that data demonstrates no significant increase trend between 1850 and 2005.
What are VOCs?
VOC stands for volatile organic compound. They are organic chemicals that easily vaporize in the atmosphere.
What major energy source is considered to be the cleanest?
Natural gas is regarded as the cleanest burning fossil fuel, producing less pollution than oil or coal.
What are umbrophobia and homochiophobia?
Umbrophobia is an irrational fear of the rain, while homochiophobia is a fear of fog.
What are the National Centers for Environmental Prediction, NCEP?
Part of the National Weather Service, the National Centers for Environmental Prediction include the following centers: the Aviation Weather Center for monitoring weather conditions that could prove hazardous to airplane and space flights. The Climate Prediction Center is focused on how climate affects the country, as well as on short-term climate changes. The Environmental Monitoring Center is a research center studying ways to improve weather-related sciences, including climatology, hydrology, and ocean weather prediction. The Hydrometeorological Prediction Center provides rain forecasts for the upcoming week. The Ocean Prediction Center is responsible for issuing ocean weather warnings in the Atlantic and Pacific Oceans north of the 30th degree parallel. The Space Weather Prediction Center warns of weather conditions on Earth and in space that could put space missions at risk. The Storm Prediction Center keeps a watchful eye on tornadoes, hurricanes, and other hazardous weather within the lower 48 U.S. states. The Tropical Prediction Center monitors tropical weather systems within the United States, as well as surrounding regions.
How much energy does one bolt of lightning contain?
A bolt of lightning contains enough energy to light a 100-watt light bulb for 3 months. To be more technical, each stroke of lightning has about 30,000 amps and 1 million volts of power, on average. Some superbolts can have up to 300,000 amps of power.
What caused the Bhopal disaster?
In December 1984, the U.S. owned Union Carbide pesticide plant in Bhopal, India, leaked toxic chemicals, methyl isocyanate gas, that killed over 3,800 people. It was the worst industrial accident in history. Union Carbide paid a fine of $470 million to avoid facing criminal charges.
What is a January thaw?
Mostly seen in the northeastern United States and in the United Kingdom. A January thaw is a brief midwinter period usually late in the month in which temperatures moderate somewhat. The Midwest can also experience such thaws, occasionally with startling changes in temperature. For example, in January 1992, northwestern Iowa had a January thaw in which temperatures rose from -60 degrees Fahrenheit, -51 degrees Celsius, to above freezing in just 2 weeks. While the change was a welcome one for many people, the thaw sadly melted the giant ice palace sculpture that had been on display for the St. Paul Winter Carnival.
How does lightning work?
The anatomy of a lightning stroke is surprisingly complex. For lightning to occur, of course, there needs to be a source of electricity, an electrical storm. Thunderstorms contain clouds that work like capacitors. The tops of the clouds have a positive charge and the bottoms are negatively charged. Scientists believe that this electrical charge may build up as the result of electrons being exchanged by particles within the clouds as they collide with one another due to temperature differences within the cloud, though just how this happens is a matter of debate. As the difference between the positively charged cloud tops and negatively charged bottoms increases, an electric field is generated. As the charge within the cloud builds, it has an effect on the surface of the Earth directly below, as well as objects on top of the ground. The negative field on the bottoms of the clouds repels electrons on the ground, which in turn causes the land below the storm to become positively charged. As the charge builds and builds, the air between Earth and cloud becomes ionized air molecules, break down into electrons and positively charged ions, transitioning into a plasma state. This plasma now serves as a conductor between the clouds and the ground below, or to other clouds, or into the surrounding air. Next, the cloud sends out step leaders, which are precursors to the oncoming flash of lightning. Think of them as ionized paths and streams of electrons that are like feelers that the cloud sends out, searching for the best path for the lightning bolt to flow through. Sometimes they may be visible as faintly glowing purplish streaks. Meanwhile, as the step leaders are sending exploring fingers outward, the positively charged ground or other receiving object is sending out feelers upwards. These feelers, called positive streamers, don't always connect with the step leaders. But when they do, the circuit is completed and the fireworks are ready to begin. Positive streamers can emerge from any inanimate or living object, including people. Like railway workers completing a railroad. Once the two ends of the path join, the train can drive through. This is the lightning bolt, an explosion of energy that occurs as nature attempts to equalize the charge between cloud and surface.
Who discovered how rainbows form?
In 1304, a German Dominican monk named Theodoric von Freiburg, 1250–1310, showed that light passing through a large glass globe filled with water would create a rainbow because light waves were bent through refraction, reflection, and dispersion. He speculated that the same process occurs in raindrops, creating natural rainbows.
Does the Sun have an atmosphere?
Yes, in a manner of speaking. Since the Sun is made primarily out of hydrogen, 73%, and helium, 25%, in a plasma state, there's no visible solid surface to distinguish a dividing line between the Sun's body and its atmosphere. The surface of the Sun is a layer called the photosphere that is about 300 miles, 480 kilometers, Thick and has an average temperature of about 10,000 degrees Fahrenheit 5,500 degrees Celsius, above that is a second layer, called the chromosphere, that is thousands of miles thick, and is somewhat cooler 7,800 degree F, 4,300 degrees Celsius. Above that is the Sun's corona, which is where temperatures kick into high gear. Temperatures in the corona average about 1.8 million degree F, 1 million degree C.
What was the Donora smog disaster of 1948?
One of the most shameful chapters in environmental history occurred on October 30 and 31, 1948, in the industrial town of Donora in Washington County, Pennsylvania. The 14,000 residents were mostly supported by steel mills, which found the location by the Monongahela River just 30 miles, 48 kilometers, from Pittsburgh to be ideal. The mills provided good-paying jobs, but the blast furnaces they used produced massive quantities of soot, sulfur dioxide, and other pollutants. In addition, the town was home to a zinc smelting plant and a sulfuric acid plant. As if that weren't enough, the natural climate of the town made foggy weather a regular occurrence. The industry combined with the weather during a horrible Halloween season in 1948, creating such thick brown air that it was nearly impossible to see where one was going. 500 of the residents fell ill from various respiratory problems and 22 people died. 17 from complications from asthma or heart disease, and 2 from tuberculosis aggravated by the filthy air.
What is a rope tornado?
A rope tornado is simply a descriptive phrase referring to a tornado that has a thin, bending, rope-like appearance. Some people make the bad mistake of thinking that rope tornadoes are regular tornadoes that are beginning to dissipate. Dissipating tornadoes are described as roping out. Actually, they can be just as intense as tornadoes with much wider funnels.
What is a heat burst?
In a manner similar to what happens when a Santa Ana wind rushes down into the low coastal areas of Southern California, a heat burst raises temperatures by compressing air. Usually associated with thunderstorms, heat bursts typically occur during the night when turbulent air from as high up as 20,000 feet is forced downward as a storm begins to break up and dissipate. Meteorologists theorize that this happens when virga rain that evaporates before reaching the ground, is present in dry, cold air. The resulting denser air is pulled down by gravity, increasing air compression near the ground rapidly and causing temperatures to rise unexpectedly. In Waco, Texas, on June 15, 1960, it was reported that a heat burst caused the temperature to soar to 140 degrees Fahrenheit. 60 degrees Celsius, for a brief period that was accompanied by winds of about 80 miles, 129 kilometers, per hour. More recently, in May of 1996, temperatures rose from about 88 degrees Fahrenheit 31 degrees Celsius to 101 degrees Fahrenheit 39 degrees Celsius. In the towns of Chickasha and Ninica in about 30 to 40 minutes. And on August 3, 2008, Sioux Falls, South Dakota, saw the temperature shoot up from about 72 degrees Fahrenheit 22 degrees Celsius to 101 degrees Fahrenheit 39 degrees Celsius during gusting winds of 50 to 60 miles, 80 to 100 kilometers, per hour. Perhaps most remarkable was a heat burst during the recent heat wave and fires in Australia. On January 29, 2009, at 3 a.m. a heat burst maxed out thermometers at 107 degrees Fahrenheit 41.7 degrees Celsius.
How did people discover that Earth has a magnetic field?
The ancient Chinese were the first to use magnets as compasses for navigation. Though they did not know it, these south-pointing needles worked. Because the magnets align themselves with Earth's magnetic field. Since Earth's magnetic poles have been very close to the rotational north and south poles, compasses point almost exactly north and south in most parts of the world. Over time, scientists started making a connection between lodestones, permanent magnets, and the nature of Earth itself. The English astronomer Edmund Halley, 1656 to 1742, for example, spent 2 years crossing the Atlantic on a Royal Navy ship, studying Earth's magnetic field. Later, the German mathematician and scientist Carl Friedrich Gauss, 1777 to 1855, made important discoveries about how magnets and magnetic fields work in general. He also created the first specialized observatory for the study of Earth's magnetic field. With his colleague Wilhelm Weber, 1804 to 1891, who was also famous for his work with electricity, Gauss calculated the location of Earth's magnetic poles. Today, a unit of magnetic field strength is called a Gauss in his honor.
When did maps displaying cold and warm fronts first get published in the United States?
Although the discovery of weather fronts was made during World War I, it was not until the 1930s that U.S. weather maps began to use symbols to indicate them.
How thick is Earth's atmosphere?
Earth's atmosphere extends hundreds of miles beyond its surface. But it is much denser at the surface than at high altitudes. About half of the gas in Earth's atmosphere is within a few kilometers of the surface. And 95% of the gas is found within 12 miles, 19 kilometers, of the surface.
How dangerous are heat waves to people?
Heat waves are responsible for some of the most lethal weather disasters in history. In fact, in the United States the heat wave of 1980 caused more deaths, between 10,000 and 15,000, depending on sources, than the 1900 hurricane that killed between 8,000 and 12,000 people in Galveston, Texas. More recently, in 2003 a heat wave in Europe struck, killing somewhere between 35,000 and 50,000 people. The heat had a particularly lethal effect on the people of France, where over 14,800 people died of heat-related problems, mostly heat stroke. In France, fewer people have air conditioning in their homes, and many elderly living in apartments succumb to the suffocating temperatures.
Why is air pollution in China such a huge problem?
In recent years, China has been experiencing an unprecedented economic and industrial boom. Cities are growing, manufacturing, with the exception of the onset of a worldwide recession in 2008, has been flourishing, and living standards are rising. This has been great news for many Chinese citizens. But it has come with a cost, a huge environmental problem. Although China has many environmental regulations on the books, it has had tremendous problems enforcing them. The result is that the country is probably the most polluted on the planet, with only India as a rival in this infamous area. The air quality in about 2/3 of the cities is considered unhealthy for people. Acid rain is damaging crops, and life expectancy rates are dropping because of pollution-related health issues. The Chinese government is not unaware of this shameful problem, and the country made news in 2008 when it hosted the Olympic Games. Heavy restrictions were placed on auto traffic and factories so that the air would be clear enough that the athletes would not be sickened by the smog.
Is there a sunspot cycle?
Yes. Sunspot activity goes through a two-cycle pattern of high and low activity. One that lasts about 11 years, more accurately, about 10 years, 6 months, and also an 88-year cycle of highs and lows. And astronomers speculate an even longer pattern might be possible. The first person to observe sunspot cycles was German astronomer Heinrich Samuel Schwab, 1789 to 1875. Originally a pharmacist, Schwab became an amateur and then professional astronomer. Wondering whether there was another planet besides Mercury and Venus close to the Sun, he accidentally discovered sunspots and became completely fascinated by them. From 1825 until near the end of his life, he observed the Sun daily. recording the number of sunspots he observed. From these observations, he noticed that there were periods of greater and lesser activity, which he thought came in cycles of about 10 years. A fairly close approximation, given the quality of telescopes at the time.
When do the seasons start and end?
When it comes to climate and weather, the seasons start at different times of year depending on where one is on Earth. Astronomically speaking, though, the first day of spring happens on the vernal equinox. The first day of summer happens on the summer solstice, the first day of fall happens on the autumnal equinox, and the first day of winter happens on the winter solstice. When it comes to official weather statistics, the seasons are considered to be as follows. Winter is December through February, spring is March through May. Summer is June through August, and fall is September through November. So, if you hear a report, for example, that last summer was the hottest on record, that means June 1st through August 31st, and not June 21st through September 21st, which is how it is marked on your typical calendar.
Why do people live in floodplains?
People have lived in floodplains for thousands of years. Fertile land for agriculture lines the floodplain, and the nearby water source makes life easier. Unfortunately, when the river does flood, these communities are severely damaged and people suffer. Hazard mitigation, such as levees, dams, dikes and other structures, attempt to limit damage during floods. Sometimes, when the structures fail, such as a levee breaking, large areas are inundated with water. Inhabitants of floodplains must balance the risks with the rewards of living in such an unpredictable environment.
Are there different categories of rainfall?
Yes. Rainfall is categorized into 3 types. Convective rain happens when the sun warms the air near the ground, as the air then rises. It cools in the higher altitudes and water droplets form, creating a rain shower. Orographic rain is caused when air masses are elevated due to a geological feature such as a mountain. At the same time, landforms create a kind of squeegee effect on moisture as it runs into mountains. The result is the same as with convective rain, because as the air cools in the higher elevation, rain may result on the windward side of the hill or mountain. Cyclonic rain is the result of interacting air masses, which collide and force warm air masses upwards. This type of rain formation often results in strong thunderstorms or hurricanes.
Can a hurricane be stopped?
For all practical purposes, no proposals have been suggested, such as cloud seeding techniques, but to date science has yet to come up with a solution. During the 1950s, the U.S. federal government launched the Storm Fury project, which was an effort to dump silver iodide crystals near the eyes of hurricanes. The theory was that the seeding would generate a secondary eye in the storm, which would then hamper or even cause the original eye to collapse. Several experiments were conducted in 1961, 1963, 1969, and 1971, but while sometimes the results seemed promising, the data was inconclusive. Hurricane Esther, in 1961, appeared to be weakened by as much as 30% through seeding. But there was no proof that the storm didn't just weaken all by itself. The government gave up the project in the 1970s, and while private companies have continued some of this research, most meteorologists believe that there is just no practical way to destroy a hurricane. The problem seems to be the fact that, for it to work, cloud seeding requires supercooled water. But hurricane clouds contain insufficient supercooled moisture.
Which Chinese scholar first hypothesized about climate change?
In the 11th century c. Chinese writer Shen Kuo, 1031–1095, noticed that bamboo plants were buried in the ground near Shanbei. This region was far too northerly for bamboo to grow in Shen's time, and he therefore reasoned that the climate there had once been very different.
What happened because of a dust storm in 1977?
One of the worst dust storms to hit the United States since the Dust Bowl occurred in February 1977, when fierce winds blew over plowed fields from Colorado to Texas, kicking up a huge dust cloud. The dust storm dumped 3 million tons, 2.7 metric tons, of soil onto the state of Oklahoma. The cloud continued through Mississippi and Alabama, dramatically raising particulate pollution, and continued across the country and far into the Atlantic Ocean.
Who figured out that temperatures rise in the stratosphere?
Pioneering French meteorologist Léon-Philippe Tisserand de Bord, 1855–1913. Conducted an experiment using helium balloons and temperature sensors.
Is there much permafrost in the lower 48 U.S. states?
There is no permafrost in the lower 48 states. Those states such as North Dakota and Minnesota do often experience conditions where frost levels penetrate the ground to depths extended 30 or more inches, 76 centimeters.
What are coronas and anticoronas?
A corona is a glowing white ring edged with blue on the inner side and red on the outer, and seen around the moon, or less often, around the sun, usually during eclipses. It is caused by light being diffracted by water droplets in a thin cloud, such as an altostratus cloud. The smaller the droplets of water in the air, the larger the corona will appear. An anticorona, sometimes called a glory or Brockenbau, is one or more concentric rings that appear when an object, such as an airplane, casts a shadow on a thin layer of clouds. The anticorona will appear on the side opposite of where the light source, sun or moon, is.
What is the difference between freezing rain, sleet, and hail?
Freezing rain is rain that falls as a liquid but turns to ice on contact with a freezing object to form a smooth ice coating called glaze. Usually freezing rain only lasts a short time, because it either turns to rain or to snow. Sleet is frozen or partially frozen rain in the form of ice pellets. Sleet forms when rain falls from a warm layer of air, passes through a freezing air layer near the Earth's surface, and forms hard, clear, tiny ice pellets that can hit the ground so fast that they bounce off with a sharp click. Hail is a larger form of sleet.
What are supercooled droplets?
A supercooled droplet is a cloud droplet that remains in its liquid form at temperatures far below the freezing point, as low as -40 degrees Fahrenheit. Clouds formed of supercooled droplets pose potential hazards to aircraft that fly through them, because they can cause ice to form on wings and propellers. When low to the ground in the form of fog, supercooled droplets can also create hazardous road conditions by causing ice to form on streets and highways. On the other hand, supercooled droplets can also result in great beauty when they paint the landscape in a sparkling layer of ice that makes trees and other plants shine.
What is the ring of fire?
There is a circular region that surrounds the Pacific Ocean where volcanic activity is particularly high. This is known as the Ring of Fire and includes coastal areas in Japan, Russia, Alaska, Canada, Oregon, Washington State, California, Mexico, Southeast Asia, and many South Pacific islands. The ring stretches some 40,000 miles, 64,000 kilometers, and includes 3/4 of the planet's volcanoes. Among those are Mt. St. Helens and recently active volcanoes in Alaska, such as Mount Spur, which erupted in 1992, and Mt. Redoubt, which erupted March 22, 2009, near Anchorage.
What is meant by a trace of precipitation?
When the amount of rainfall is too little to be measured by a standard rain gauge. The precipitation is labeled a trace.
What are spiral bands?
The clouds arranged in curving bands that form the outside of a hurricane, rather like those in a spiral galaxy, are called spiral bands. They can extend for several hundred miles beyond the eye of the hurricane.
Why do flash floods kill so many people?
Simply put, people don't seem to recognize the power of flash floods and the fact that even a half foot of rushing water can knock down an adult and sweep him or her away. Moving flood waters just a few feet deep are capable of pushing cars and small trucks. Floods can either drown you, or they can kill you by carrying deadly debris. The other factor, of course, is that flash floods catch people by surprise. And if they happen at night, those who are sleeping can certainly be caught unawares. Sometimes, too, people can just lack a little common sense. There have been many stories of people who were standing in dry river beds when a flash flood suddenly barreled down on them, instead of running up the river bank and to safety. They ran downriver in the vain hope of outrunning the rushing waters. This is how a number of deaths occurred during the 1976 flood that hit Big Thompson, Colorado.
Can some people with arthritis or aching joints predict the rain?
Many people claim that they can feel a rainstorm approaching because they will feel an ache in their knee, a throb in a tooth, or some other pain in their bodies. In a research study conducted by the University of Pennsylvania, scientists learned that, indeed, people with arthritis could sense when humidity levels went up and pressure dropped, both of which are good indications of an approaching storm.
What was the Great Hurricane of 1938?
Possibly the worst storm to ever hit the American Northeast since the arrival of Europeans. The Great Hurricane of 1938 wreaked havoc throughout New England and down as far as Long Island. 600 people died as a result of the storm in what has also been called the Long Island Express.
What is the story behind the man who lent his name to the Humboldt Current?
Next to Napoleon Bonaparte, Alexander von Humboldt, full name, Friedrich Wilhelm Heinrich Alexander Freiherr von Humboldt. 1769–1859, was largely regarded as the most famous man in Europe in his day. Educated in everything from finance and languages to astronomy, geology, and anatomy, Humboldt had a passion for science and travel. Most notable was his voyage to South America, 1799–1804, during which he explored the natural landscape, making observations about the animal and plant life, as well as geological and astronomical observations. From this experience, he originated the idea that species vary depending on the climate, which varies with temperature and elevation. He also correctly surmised volcanoes probably align themselves along geological fissures in the Earth's crust. Humboldt connected the dots between geology and weather, noting how climate changes with elevation. He also was the first to observe how the Earth's magnetic field varies with latitude, and made observations that would later contribute to theories on how weather systems are generated with the planet's middle latitudes. When Humboldt's expedition reached the Pacific, he discovered the Peru Current, which is now also known as the Humboldt Current. For all his explorations and discoveries, Humboldt became a hero when he arrived back in Europe. He wrote about his journeys in the epic 30-volume work The Voyage of Humboldt and Bonpland, 1805–1834, and was even more lauded for his 2-volume Cosmos, 1845–1847, in which he attempted to unify many scientific disciplines to describe the complexity of nature as a whole system.
Who was Alexander Buchan?
The most prominent meteorologist of the 19th century, Scottish scientist Alexander Buchan, 1829–1907, is sometimes referred to as the father of meteorology. He is credited with making great advances in weather charts, including his use of isobars to connect areas of equal pressure in lines that are now familiar to anyone who has seen a weather map. He also understood the importance of ocean and atmospheric circulation like no one else of his age. In his 1868 book, Handy Book of Meteorology, he made long-range weather predictions, the first person to do so in a printed publication. Among his most famous ideas was what are now called Buchan spells. These are predictable blips, abrupt changes in temperature in the usually smooth transition in weather between the seasons. For instance, he predicted that a cold Buchan spell typically occurred the week before Valentine's Day. Buchan was wise enough, though, to know that such a rule could never be hard and fast, and admitted that his Buchan spells allowed for some variations and sometimes never occur at all.
Who was the first person to classify clouds?
The French naturalist Jean Lamarck, 1744 to 1829, was the first to propose a system for classifying clouds in 1802. His work, however, did not receive wide recognition. A year later, the Englishman Luke Howard, 1772 to 1864, developed a cloud classification system that has been generally accepted and is still in use today. In Howard's system, he distinguished clouds according to their general appearance. Heap clouds versus layer clouds, and their height above ground. Latin names and prefixes are used to describe these characteristics. The shape names are cirrus, curly or fibrous, stratus, layered, and cumulus, lumpy or piled. The prefixes denoting height are CO, high clouds with bases above 20,000 feet 6,000 meters, and alto, mid-level clouds from 6,000 to 20,000 feet 1,800 to 6,000 meters. There is no prefix for low clouds. Nimbo and nimbus is also added as a name or prefix to indicate that the cloud produces precipitation.
Why did the United States refuse to sign the Kyoto Protocol?
The United States refused to sign the Kyoto Agreement in 1997, and again in 2001, for a number of reasons. One major reason was that China and India were exempt from the stringent pollution controls that would have been imposed on the United States. So US representatives said this would allow for an unfair trade advantage. Furthermore, the US government was convinced that the protocol would severely damage the economy in general, costing many Americans their jobs and making the nation more dependent on foreign energy suppliers.
What is an aurora?
An aurora is a bright, colorful display of light in the night sky. Aurorae are produced when charged particles from the sun, usually solar wind particles, but sometimes coronal mass ejections as well, enter Earth's atmosphere. The particles are guided to the north and south magnetic poles by Earth's magnetic field. Along the way, these particles ionize some of the gas molecules. They encounter by drawing away electrons from those molecules. When the ionized gas and their electrons recombine, they glow in distinctive colors, and the glowing gas undulates across the sky.
How do factory farms contribute to air pollution?
One of the debates currently raging between environmentalists and the agricultural industry concerns factory farms. These are large, usually corporate-owned facilities in which there are high concentrations of livestock or where vast areas of cropland contribute to fertilizer runoff. When it comes to air pollution, such farms are a major contributor to the problem. So much animal waste is generated by factory farms. that large lagoons filled with manure and urine have to be built to maintain all of it. Some of this liquid manure is dispersed by spraying it onto crops as fertilizer. But that doesn't really help the issue. These wastes generate large amounts of noxious pollutants, including ammonia gas, methane, and hydrogen sulfide, as well as carbon dioxide. Such gases contribute to acid rain and ozone depletion. In addition, livestock flatulence, to put it bluntly, burping and farting cows, is another source of methane gas. According to the Environmental Protection Agency, 20% of methane gas generated by human civilization comes from agricultural activities.
Why do meteorologists refer to the Reynolds number when talking about turbulence?
The Reynolds number is a mathematical result computed by calculating the ratio of inertial to viscous forces. Put in more understandable English, it measures how fluids move through an area of defined diameter. It is named after English physicist and engineer Osborne Reynolds, 1842 to 1912. Who was interested in how water flows through rivers and in waves and tides. However, it can also be used in terms of air flowing through the atmosphere, and thus has applications in meteorology, where Reynolds's formula is used to calculate air turbulence.
What are the stages of a thunderstorm?
Thunderstorms have three stages: cumulus, mature, and dissipation. In the cumulus stage, warm, humid air near the ground is pushed upwards by strong thermals, or by the collision of air masses coming in from several directions at once. As this moist air rises, it cools and the heat that is released enters the surrounding air, causing convection that, in turn, causes more air to rise. A loop that feeds off itself causes a rapid increase in cloud formation. Temperature differences between lower and higher altitude, and rainfall. The storm reaches its second stage, the mature stage. When air has reached its cap and is not rising any farther. At this point, cumulonimbus clouds become cumulonimbus incus, thunderheads, with water droplets freezing at the top, thawing into rain as they descend. As the mixture of water, ice, and wind becomes more turbulent, an electrical charge builds up, aligning the ice crystals within the clouds until a bolt of lightning is discharged. This happens repeatedly until the storm weakens in the dissipation stage.
What is radar?
Radar is an acronym for radio detection and ranging, and it uses radio waves to detect objects in the atmosphere. It was first devised in 1904 by the German inventor Christian Hülsmeyer, 1881 to 1957. who called his radar detector a telemobiloscope and patented the device in 1906. The original purpose of his invention was for ships to be able to detect each other so that in poor weather conditions, e.g., heavy fog, they would not run into each other. Sadly, this brilliant invention did not catch on at the time. If it had, some speculate that the 1912 Titanic disaster could have been avoided. Another concept that Hulsmeyer came up with was the remote control. He believed, correctly, that radio waves could be used to turn mechanical devices on and off. Again, people ignored the concept and he never got the credit he deserved.
How often do ocean tides occur on Earth?
During a 26-hour period, each point on Earth's surface moves through a series of 2 high tides and 2 low tides, first high, then low, then high again, then low again. The length of the cycle is the sum of Earth's period of rotation, or the length of its day. 24 hours, and the Moon's eastward orbital movement around Earth, 2 hours.
What can I do to help relieve frostbite?
First of all, if you feel you are suffering from frostbite, you should seek professional medical attention while trying to keep pressure off of extremities, fingers and toes, that have been frozen. You should never vigorously rub the afflicted area, as this could cause severe tissue damage or even break off pieces of tissue. If you are unable to see a doctor immediately, a warm bath. Have the water between 100 and 110 degrees Fahrenheit 38 to 43 degrees Celsius, is a much better choice than sitting in front of a fireplace.
Has there always been an ozone layer?
No. Before plants evolved on the planet, there was no ozone layer. Because plants are responsible for converting carbon dioxide in the atmosphere into oxygen molecules. So, life on Earth actually began to evolve before there was an ozone layer.
What is meteorology?
Meteorology is the scientific study of the weather and, more specifically, how changes in the weather may be forecasted.
Why is it impossible to find a pot of gold at the end of a rainbow?
Even if there were a pot of gold at the end of a rainbow, you could never reach it because the rainbow moves away from you as you approach it. The rainbow will always be positioned opposite the azimuth of the sun.
Am I safe from lightning if I hide indoors?
Well, you are generally safer to stay indoors, but not 100% safe. Most people who are struck by lightning are injured when they are outside. And many injuries and deaths occur when people stand next to trees, so trees are not the best place to find shelter. There have been incidents, however, when people inside their homes have been injured as lightning runs through power lines and pipes and can escape through appliances and plumbing indoors. In one incident that occurred in Chicago Heights, Illinois, on October 24, 1991, a lightning stroke made its way through a cable line, entering a house and causing a bed to catch fire. Such cases are quite rare, however.
What do butterflies have to do with chaos theory?
American mathematician and meteorologist Edward Norton Lawrence, 1917 to 2008, came up with chaos theory as a way of explaining the unpredictable way in which mathematical and natural systems, including weather, behave. The idea was that even the tiniest changes in initial conditions of a complex dynamic system can lead to huge, measurable effects over time. As a colorful metaphorical illustration of this concept, he posed that a single butterfly flapping its wings in Brazil could be the instigator of a tornado in Texas. He called this the butterfly effect.
What gases and chemicals are considered to have the greatest effect on global warming?
Anything that increases carbon dioxide, CO2, levels is a risk factor in heating up the planet. In addition to CO2, methane gas, CH4, and chlorofluorocarbons, CFCs, are culprits in global warming. Methane, from livestock, coal mining, and also natural sources like peat bogs and termites decomposing wood, is actually 25 times more effective in holding heat within our atmosphere. And CFCs are 20,000 times more efficient than CO2. Methane gases during the 1990s were rising at an annual rate of about 0.8%. From 1997 to 2007, however, methane levels stabilized. And scientists believed that a balance had been reached between production of methane gas and its rate of dissipation in the atmosphere. In 2007, however, a sudden spike in methane levels was noted. Especially in the northern hemisphere, for reasons not well understood. Theories include the idea that global warming increased methane production from wetlands bacteria, i.e., the result of melting permafrost, especially in Siberia, or that the amount of O hydroxyl free radical, which breaks down methane, is decreasing in the atmosphere. Today, the amount of methane in the air is more than twice what it was before the Industrial Revolution. About 1,775 parts per billion versus about 700 parts per billion. The current rate of increase for methane is about 10 parts per billion annually, which is considered a significant spike. Meanwhile, because of government regulations, CFC levels have been steadily decreasing in the atmosphere, which is particularly good news for the ozone layer.
Do other planets in our solar system experience weather?
Many planets and even moons in our solar system have atmospheres and, therefore, weather. The gas giants Jupiter, Saturn, Uranus, and Neptune all have very thick atmospheres which include storms and even lightning. Lightning has been observed on Jupiter, Saturn, Io, and Titan, and is speculated to exist on Venus. Jupiter, of course, is famous for the huge swirling Great Red Spot, which is a windstorm 8,500 miles, 14,000 kilometers, wide and 16,000 miles, 26,000 kilometers long that astronomers estimate has been ongoing for at least 400 years. Saturn, too, has a thick atmosphere topped by crystallized ammonia clouds. It also has a great white spot. But this storm lasts for about a month and then fades, recurring at intervals. Uranus has a distinctive, blue-green atmosphere made mostly of hydrogen, 83%, and helium, 15%. Neptune also has a blue color, which is why it is named after the Roman god of the sea, with a hydrogen-helium-methane atmosphere. Below this upper atmosphere, astronomers believe Neptune has a lower atmosphere made of ammonia, crystallized methane, and ionized water. Even deeper may be a layer of hydrogen sulfide. The winds on all of these planets are believed to be very powerful. Neptune, for instance, has winds reaching 700 miles, 1,100 kilometers, per hour. The planet has a great dark spot, that is an ongoing storm about the size of Earth's moon, and a smaller, white storm that has the whimsical name of Scooter. Not counting Earth, the inner planets Mars, Venus, and Mercury all have atmospheres. The atmosphere on Mars is very thin, and it has an air pressure about 1% that of Earth's. Theories abound as to why Mars lost its atmosphere, ranging from giant asteroids smashing into the planet and ripping away its air, to the lack of plate tectonics providing sufficient heat, to the idea that the planet somehow lost its magnetosphere. Without much atmosphere, Mars does not have much weather. Mercury, similarly, has virtually no atmosphere and is essentially a big rock in space. Venus is far more interesting than either Mars or Mercury, in terms of atmosphere. It is a planet with an atmosphere too rich in carbon dioxide, and consequently it experiences a runaway greenhouse effect that heats the surface to 900 degrees Fahrenheit. 500 degrees Celsius, which is hot enough to melt metals like lead, tin, and zinc. Poor Pluto, which has been downgraded in status from planet to planetoid, has a thin atmosphere containing nitrogen, methane, and carbon monoxide. Several moons in our solar system also have atmospheres. Of these, Saturn's Titan is perhaps the most interesting. Its dense atmosphere, 50% denser than Earth's, contains 98.4% nitrogen and 1.6% methane. Astronomers believe that Titan has lakes and seas composed of liquid methane and nitrogen, and that it experiences rain showers made of methane. A smoggy, orange haze made of hydrocarbons envelops the atmosphere. Some other moons have thin atmospheres, such as Neptune's Triton, and Ganymede, which is another moon circling Jupiter, is believed to have a water ocean beneath a layer of ice.
What is a fulgurite?
When lightning strikes sandy soil, the soil melts into a glassy stone called a fulgurite. These stones can appear branch or root-like, almost as if the bolt of lightning has been fossilized or petrified somehow. The glassy material in the fulgurite is known as lechatelierite, a substance that can also be formed by meteors striking the ground. One of the largest fulgurites ever found is housed at Yale University's Peabody Museum of Natural History and is about 13 feet, 4 meters, in length.
What is a hypercane?
Professor Carey Emanuel at the Massachusetts Institute of Technology is an authority on using computer models to simulate hurricane activity. In one extreme scenario, Emanuel hypothesized what might happen if a large asteroid hit one of Earth's oceans. Of course, there would be monstrous waves and immense heat generated by the impact. But there would be another side effect as well, a hypercane. A hypercane would occur after the impact because deep ocean waters would heat up. The result would be a strange hurricane that would only be about 10 to 20 miles. 16 to 32 kilometers, across but would have incredible winds reaching 500 miles, 800 kilometers, per hour. Such a hypercane would also be capable of jettisoning moisture upwards of 25 miles. 40 kilometers, into the atmosphere.